Okay, this video tutorial looks at the mathematical strand of geometry, and more specifically, we're going to focus our understanding on similarity. So let's talk about what it is that makes two shapes similar. Well, there are two ways that you can check if two shapes are actually similar. The first one is to determine if their side lengths are in the same ratio. Okay, so if we look at our two triangles, we have a 2 on this side here, so 2 meters, and its corresponding side on the next shape is 8 meters. So we've actually got a multiplier of 4. If we then look at another corresponding shape, we have a side length of 3 meters and a side length of 12 meters. So again, we have a multiplier of 4. So we can say straight away, yes, these side lengths are in the same ratio. The next thing we need to check is if the shapes are actually equiangular, as in they have the same sized angles. Well, we know that shape A has an angle of 60 degrees, but we don't know what's up here. We know that both shapes have right angles here, and we know that shape B has an angle of 30 degrees here. Now we can do a quick calculation, and we can say that there's 180 degrees in a triangle. That must equal 90 degrees for our rectangle, for our right angle, 30 degrees for the angle down here, plus our missing angle here. Now we know that 90 plus 30 is 120 degrees. Therefore, x is going to equal 180 degrees, take 120 degrees, which is going to give us our answer of 60 degrees. So we can say that x is in fact 60 degrees, which means that because both these triangles have right angles and they both have 60 degrees, we know the other angle must be 30 degrees, therefore they are equiangular. So let's have a look at an example question. It says determine whether the following pairs of figures are similar. So we're going to look at question A first. Now, first thing we want to do is we want to see if their sides are in the same ratio. Well, we have 4 centimeters along here and 6 centimeters along here, so corresponding sides. We know that that's a multiplier of 1.5 or 3 over 2. We know by looking at our other corresponding sides, we have 2 and 3. So that's actually a multiplier of 1.5 or 3 over 2. So we know the multiplier is the same, so the sides must be in the same ratio. And we also know that they are equiangular because they have 4 right angles in each of the corners. So therefore, they are in the same ratio, they're equiangular, therefore they must be similar. In our second example, we're going to look at some of the ratios of the side lengths. So our first one here, we have on the bottom, we've got a 4 and a 10. So we've actually multiplied 4 by 2.5. We've got a 3 and a 9, and we've multiplied that by 3. And we've got a 2 and a 4, and we've multiplied that by 2. So we can see here straight away that we have different multipliers for each of the different sides. So therefore they are not in the same ratio, so therefore they are not similar figures. Okay, so here is a practice question I would like you to have a go at. Essentially, you just need to determine if the two shapes below are similar, so whether their sides are in the same ratio, and whether they are equiangular. Please feel free to pause the video, see if you can answer the question. Once you think you've got the answer, continue the video, and we'll see how you went. Okay, so let's see how you went. If we start with the corresponding sides to check if they're in the same ratio, you can see the top side here is 15 meters and its corresponding side is 9 meters. That means we're actually going to have a multiplier of 3/5. If we then look at the other corresponding sides, we've got 10 and 6. We also have a multiplier of 3/5. So therefore we know the sides are in the ratio. So that's great. So ratio, tick. Now we need to see if they're equiangular. Now what you'll notice is that there's 70 degrees here and there's 110 degrees there. But what you might also notice is that these lines are actually parallel. And the rules for parallel lines say that the interior angles of a parallel line must add up to 180 degrees. So if we add 110 degrees and 70 degrees, that gives us 180 degrees. Therefore, we can say that this angle here must be 110 degrees, and therefore they are equiangular. And therefore these two shapes are in fact similar.